Hello students, today we will learn about bisection method of numerical analysis, which is a subtopic of engineering mathematics. So by the help of bisection method, we learn how to find out the approximate solutions of a given function. Means in case we want to find out roots of a given function, then how to find the approximate solution of that. So without wasting time, let's come to the topic. So first of all, we have to play a small game before learning the bisection method. Suppose that there is a number line, you can see scaled number line, and the two ends are marked as 2 and 3, means it is scaled, means there is a regular division in this number line. And in case I ask you that where is the number 2.5, then it will be exactly in middle, 2 plus 3 by 2, like this. Okay. And suppose I am choosing a number 2.78 in this number line. Now the game is that you have to get a point closer to this number 2.78 just by taking average of two numbers in this number line. Okay, means you have to find a point which is very closer to this number 2.78, just taking the average of two numbers which exist in this number line. So let's start. See, this is 2 and 3, this is number 2.78. 2 plus 3 upon 2, that is 2.5. So 2.5 is in middle, which is toward left hand side of this 2.78, because it is smaller than 2.78. So it is closer to 2.78. We want more closer. So 2.5 plus 3. 3 is toward right hand side, 2.5 toward left hand side of 2.78. So 2.5 plus 3 upon 2, 2.75. Now it is much closer. We want more closer number. Then 2.75 is toward left and 3 toward right. Then 2.75 plus 3 by 2, 2.875. So 2.875 will be a bit right to this number 2.78. We want more closer number to this 2.78. Now we can do one thing. 2.875 is toward right hand side, a bit right, and to the left the most closest number is 2.75, means the closest number in left to this 2.875 is 2.75. So 2.75 plus 2.875 upon 2, that is equals to 2.81. So 2.81 is also closer to this 2.78. Now we want more closer, and we know this thing that 2.81 is also toward right hand side. So 2.81, and the closest number in left to this number 2.81 is 2.75. Okay, so 2.81 plus 2.75 upon 2, that is equals to 2.781, which is almost at this point 2.78. Okay, this is an exercise, this is a game just to learn properly about bisection method. Okay, now we know this thing that in mathematics for every function there is a graph, and for every graph there is a function. Okay, so suppose that this is a function, you can see in blue line, this is the graph of that function. This is y-axis, that is fx, and this is x. So when you are putting x in fx, you are getting the value of fx, which is the axis y. Okay, now you can see that this function, the graph is intersecting with the x-axis at some point. Okay, so where the fx becomes 0. So for this x, the fx becomes 0, which is called as root of the function. The root of the function is at that point where if you are putting the x, you will get 0 answer, means y becomes 0. Okay, so this is the root of the function. So you see that when x is at this point, which is the root of the function, the fx becomes 0. In case you are taking an x which is toward left hand side, you will get negative answer, means you can see that in case you are putting 1 in place of x, you are getting fx to be minus 2, you can see. So if you are toward left hand side of this root, you will always get negative answer of this fx. And if you are toward right hand side of this root, you can see if you are putting x equals to 3, then fx equals to how much? This much. This is equals to 6. So in case to the root, if you are choosing an x which is toward right hand side, then you will get always positive answer, and to the left hand side of the root, you will always get negative answer, means fx becomes negative for left hand side x, and fx becomes positive for right hand side x. So one thing is clear, that the two values of x for which fx is negative and positive respectively, means you are taking two values of x for which one value the fx is negative and for other value it is positive, the root lies somewhere within those two values. So let's learn the bisection method by the help of a question. So the question is, determine the root of a given equation, means fx equals to x square minus 3. So root means what? The point of x where it becomes, this entire function becomes 0. Okay, so let's do it by the help of bisection method. Okay, first of all we have to initially guess the two numbers. Suppose I am guessing the numbers are 0 and 1, means I believe that the root lies between 0 and 1. Okay, so putting x equals to 0, I will get what? Minus 3. and in case I am putting x equals to 1, I am getting minus 2. Both are negative. So 0 doesn't lies between minus 3 and minus 2. So this is my wrong guess. Now I am taking second guess. Suppose I say this time I am taking the numbers 2 and 3. These are the two numbers and I believe that root lies between these two numbers. So in case I am taking f2, so 2, 4 minus 3 that equals to 1, and in case I am keeping 3, so 3 square minus 3 that is equals to 6. Again it is a wrong guess because 0 doesn't lies between 1 and 6. Now I am taking the third guess. Suppose those numbers are 1 and 2. So in case I am putting 1 in this equation, what I am getting? Minus 2. And in case I am putting 2 in this equation, I am getting plus 1. Now this guess is correct. Reason being, for one value of x I am getting negative number, fx becomes negative, and for other value it is becoming positive. So since 0 lies between 1 and minus 2, therefore we can find the root between these two numbers of x, 1 and 2. So let's start our iteration. Okay, so for f1, this function becomes minus 2, and in case I am putting 2, I am getting 1. Okay, now take the average of these two numbers, 1 and 2. So 1 plus 2 by 2, that is equal to 1.5. Okay, so in case I am putting 1.5 in place of x, f 1.5 equals to minus 0.75. Okay, so I am going closer to 0. It is 0.75, which is negative. Okay, so the closest number to this 1.5, which is making fx positive, is 2. f2 is 1 and f1.5 is minus 0.75. So closest number for 1.5 for which the fx becomes positive is 2. So taking the average of these two numbers, 2 plus 1.5 by 2, that is equals to 1.75. Okay, so f 1.75 becomes what? Putting 1.75 and I will get 0.062. Okay, so f 1.75 is equals to 0.062. So I am going closer to this fx equals to 0. Now one for 1.75 fx becomes 0.062, and the closest number to 1.75 for which the fx becomes negative is 1.5. So taking the average of these two numbers, 1.75 plus 1.5 over 2, 1.625. Now putting in place of x this 1.625, I am getting minus 0.0359. Okay, so again I am going closer to 0, fx becoming closer to 0. So again I see that for this 1.625, fx becomes this. The closest number to 1.625 for which fx is positive is 1.75. So taking the average of these two, 1.625 plus 1.75 upon 2, that is equals to 1.6875. Now what is f 1.6875? That is equals to minus 0.1523. Okay, so again I am going closer towards 0. So now the closest number to this 1.6875 for which fx is positive is 1.75. So taking the average of these two, 1.6875 plus 1.75. So 1.6875 plus 1.75 upon 2, that is equals to 1.7188. So f 1.7188 equals to minus 0.0457. So again I want more closer solution. So for this 1.7188, the fx becomes this. So the closest number to this 1.788 for which fx is positive is 1.75 itself. You can see closest number for which fx is positive. So taking the average of the two, you can see 1.788 plus 1.75 upon 2, that is equals to 1.7344. So in case I am taking f1 1.7344 in place of x, I am putting this number. I am getting 0.0081, which is very close to 0. So approximately I am very much closer to the answer. So I will do one more iteration. So the closest number to 1.7344 for which fx is negative, because this number is positive. So I want second number for which the fx becomes negative is 1.788. So I am taking the average of the two. I am getting this answer 1.7266. So f 1.7266 is minus 0.0189, which is less accurate than this 0.0081. So taking this as answer 1.7344. So this is the approximate solution to this problem. So this entire process of finding the root, approximate root of a function, is called as bisection method. Why it is called as bisection method? Reason being, we are bisecting the 2 points. In a line is joining the 2 points, then actually we are taking the average of the two, which can be considered as bisection. So hope by the help of this small lecture you would have understood that what is bisection method. Thank you.